हेलो, वेलकम टू माय यूट्यूब चैनल दैट इज़ मैकेनिकल इंजीनियरिंग। आज की इस वीडियो में हम लोग डिस्कस करेंगे द डिफरेंसेस बिटवीन टर्निंग एंड मिलिंग ऑपरेशन। सो वी कैन call it as the difference between the lathe machine and the milling machine, because the turning process is carried out on lathe machine, whereas the milling process or the milling operation is carried out on the milling machine. So now we will start the differentiation. So here, for differentiating the two processes, I have made two columns. The first column, that is turning, and the second column is milling. The images below are nothing but the images for turning and milling operation respectively. So the very first point is, turning is performed to generate a cylindrical or conical surface. So basically the turning process is carried out for processing a cylindrical component or the conical component that depends on the type of motion which is given by the cutting tool. Okay, so here in this image, the first image, you can see the workpiece is attached to the chuck of the lathe machine and the single point cutting tool is attached to the turret. So the lathe machine has only two axes, that is x axis, that is along the diameter, and z axis along the length. Once the feed is given by the cutting tool, we can remove the material along the periphery of the object. So we can produce only cylindrical component over the lathe machine, or the turning process can produce only cylindrical components or the conical components. The conical component can produce when you are giving the feed along two directions simultaneously, that is along x and z. At that time you will be getting conical component. If the feed is along only one axis, that is along along z axis, then you will be getting cylindrical components. So the turning is performed to generate a cylindrical or conical shape only. Then milling is performed primarily to generate a flat surface. So the purpose of milling operation is to produce the flat surface. So in second image you can see the job is clamped over the table of the milling machine and the cutting tool is attached in the spindle of the milling machine. So as the cutting tool moves over the workpiece, you will be getting flat surface, and that is the result of your milling operation. Okay, so this is the basic difference in between turning and milling. When you want cylindrical component, in that case you have to prefer turning operation, or you have to choose lathe machine. And when you want to produce prismatic component which will have length, breadth and height, and when you want to produce a flat surface, in that case you have to go for the milling operation and you have to choose milling machine. The second point, machine tool that is used for the turning operation is called as lathe. So basically the turning operation is possible only over the lathe machine. So the first image, that is nothing but lathe machine. So this is an image of lathe machine. Here you can see the lathe machine. The lathe machine has different components like the headstock, then tailstock, tool carriage, then bed of the lathe machine, pan, leg of the lathe machine, then the slides. These are nothing but different components of the lathe machine. So in the spindle the chuck is attached, and to that chuck you can clamp your workpiece. Then you can clamp the single point cutting tool in a tool post, and then the feed can be given with the help of tool carriage. So here you can see different handles. With these handles you can move the cutting tool along x axis, that is nothing but along the diameter of the job, or you can move the cutting tool along the length of the job, that is z axis. Then at the end there is a tool post. Then the lathe machine has pan where you can collect the chips. So these are nothing but different components of your lathe machine. So the point is, machine tool that is used for turning operation is called as lathe machine. Then milling is carried out in a milling machine. So here you can see the image of milling machine. This is nothing but the second image, that is the vertical milling machine. So basically there are two types of milling machine. The first one is vertical milling machine VMC, and the second one is horizontal milling machine. So this is the image of vertical milling machine. So here you can see the table of the milling machine where you can attach the workpiece with the help of vice, and the table gives the motion to the workpiece along x and y axis, whereas the z axis motion can be given with the help of again table. You can move the table up and down, or you can move the table along left and right direction, in and out, left, right, in and out, up and down. That is nothing but three different axes of milling machine. So in the spindle you can attach the end mill cutter or the different types of cutter, and with that you can process the component or you can machine the component. So the lathe machine has only two axes, that is x and z. X is along the diameter, z is along the length, whereas milling machine has three axes, x, y, z. X and y axis, that is parallel to the table, and the z axis perpendicular to the table. Now the third point, turning process utilizes a single point cutting tool called as SPTT, single point turning tool. So in lathe machine you can use single point cutting tool. So this is nothing but an image of single point cutting tool. Here you can see a cutting insert that is brace to the tool. So you can attach the insert with the help of various techniques. You can clamp it with the help of screw, or you can directly brace it over the shank. So this is nothing but a single point cutting tool which has to be fixed with the help of tool post, and then the feed is given, and this single point cutting tool removes the material from the workpiece. In turret lathe you can attach the cutting tool in a turret. The turret will have different stations like 12 station, 16 station, and in those station you can attach this single point cutting tool. Then in milling process utilizes a multi-point cutting tool called as milling cutter. So here the second image, that is nothing but milling cutter, and this milling cutter has multiple cutting edges. In single point cutting tool the cutting is done only with the help of one point, that is nothing but nose of single point cutting tool. Whereas in milling cutter the cutting is done with the help of multiple inserts. So that is why it is known as multi-point cutting tool. The next difference, in turning, cutting tool continuously remains in contact with the workpiece during the operation. So here in the first image you can see the single point cutting tool continuously remain in contact with the workpiece during the operation. Then and then it removes the material from the workpiece. If we remove the contact, then the material will not get removed. So for removing the material, there should be a contact in between workpiece and the cutting tool, and that should be in continuously contact. That should be remain in continuous contact. So in turning, cutting tool continuously remains in contact with the workpiece during the operation. Now in milling, tooth continuously engages and disengages during the operation. That is known as intermittent cutting. So here you can see the image of end mill cutter, and that is in contact with the workpiece. The end mill cutter has multiple cutting edges, and at one particular moment only 2 or 3 teeth are in contact. Okay, entire tool is not in contact with the workpiece while cutting, as it is having multi-point. So this is an example of intermittent cutting, whereas in turning operation the cutting tool has to be in contact with the workpiece, then your material will removed. Here it is an example of intermittent cutting, where few teeth will be in contact with the workpiece and they will remove the material, and few teeth will not be in contact with the workpiece. The next difference, in turning, here the workpiece is rotated at fixed revolution per minute. This rotation provides necessary cutting velocity. So in case of turning operation, the workpiece is attached in the chuck. okay, and the workpiece will rotate with certain rpm, that is nothing but revolution per minute, and that rpm provides the necessary cutting velocity, and the cutting tool is fixed to the tool turret. So here the rotating member is your workpiece, right? So while in machining operation, few parameters are very important, like cutting speed, feed and depth of cut. So here the cutting velocity is getting uh, with the help of rotating workpiece, right? Then one more parameter is there, that is feed. So feed is nothing but during one revolution how much distance traveled by the cutting tool, that is nothing but feed, and its unit is mm per revolution. That means in one revolution how much distance is traveled by the cutting tool, that is nothing but feed. And the third parameter is depth of cut. So the workpiece is rotated at the fixed revolution per minute, and this rotation provides the necessary cutting velocity in the turning operation. Now in milling operation, the cutter is rotated at fixed revolution per minute. Rotating cutter provides the necessary cutting velocity. So this is the difference in between turning and milling operation. In turning, the workpiece is a rotating member, whereas the cutting tool is a fixed member, whereas in milling operation, the workpiece is a fixed member and the cutting tool is a rotating member, and that rotating member, that is the cutting tool, provides the necessary cutting velocity. Then the next point is, in turning, feed motion is derived by moving the cutting tool carriage. So over the lathe machine, you can give feed to the cutting tool by moving the carriage along x-axis or along z-axis. So the feed is given with the help of cutting tool or with the help of tool carriage. So here the first image, that is nothing but the tool carriage. It has different handles, and with that you can move the cutting tool along x-axis and along z-axis. Then the second column, that is milling. In milling, feed motion is derived by moving the workpiece, work table. So in milling machine, the fixed member is your workpiece, and you can move that workpiece along x, along y and along z axis by moving the table of the machine. So you can move the workpiece along x and y axis by moving the handles provided, and you can move the cutting tool by moving the spindle along z axis. Then the last point is, in turning, it can produce fragmented, discontinuous or continuous chips based on the work and tool materials, cutting parameter, etc. So in turning operation, either you will be getting fragmented, discontinuous or the continuous chips. It depends on the type of material that you are processing, then the type of tool material and the other cutting parameters. If you are processing the ductile material, obviously you will be getting continuous chips. If you are processing or if you are machining brittle component, then you will be getting discontinuous chips. Then in case of milling, milling inherently produces discontinuous chips as there is intermittent cutting. So you will be getting only discontinuous chips in case of milling operation. You will not be getting a continuous chips because the tool is not in continuous contact with the workpiece. As the cutting takes place with the help of multiple inserts, so you will be getting discontinuous chips in case of milling operation. Whereas in turning operation, you can get fragmented, discontinuous or the continuous chips, because your cutting tool is in continuous contact with the workpiece. That is the only reason. But it depends on the number of factors like the material of the workpiece, then material of the cutting tool, and other parameters like cutting speed, feed, depth of cut, that is also responsible for the type of chips. So once again we will in short revise these topics. So the टर्निंग इज परफॉर्म टू जनरेट सिलेंड्रिकल और कोनिकल सरफेस. सो टर्निंग ऑपरेशन में सिर्फ आपको सिलेंड्रिकल या फिर कोनिकल सरफेसेस मिलते हैं. मिलिंग में जो है आपको फ्लैट सरफेस मिलेंगे. टर्निंग ऑपरेशन जो है वो लेथ मशीन पे होगा, मिलिंग ऑपरेशन होगा मिलिंग मशीन पे। टर्निंग ऑपरेशन के लिए आपको यूज़ करना है सिंगल पॉइंट कटिंग टूल, वही मिलिंग के लिए आपको यूज़ करना है मल्टी पॉइंट कटिंग टूल्स लाइक कटर्स। टर्निंग ऑपरेशन में जो कटिंग टूल है वो हमेशा कांटेक्ट में रहेगा वर्कपीस के साथ, वही मिलिंग में जो है आपका जो कटिंग टूल है वो हमेशा कांटेक्ट में नहीं रहेगा, कुछ टीथ्स कांटेक्ट में रहेंगे, कुछ टीथ कांटेक्ट में नहीं रहेंगे, जिसे अपन कहेंगे इंटरमिटेंट कटिंग। यहाँ पे जो है वर्कपीस रोटेटिंग मेंबर है टर्निंग में, वेयर एज मिलिंग मशीन में जो है कटिंग टूल आपका रोटेटिंग मेंबर है। लेथ मशीन में जो है अगर आपको फीड देना है तो कटिंग टूल को मूव करना है अलोंग एक्स एंड जेड एक्सिस। वही अगर आपको मिलिंग मशीन में अगर फीड देना है तो आपको टेबल को मूव करना है, क्योंकि स्टेशनरी मेंबर आपका कटिंग टूल है जो सिर्फ रोटेट होगा, टेबल को आपको मूव करना है अलोंग लेफ्ट और राइट डायरेक्शन, इन एंड आउट डायरेक्शन, अप एंड डाउन, ये आपको टेबल को मूवमेंट देना है। और लास्ट पॉइंट, टर्निंग में जो है या फिर लेथ मशीन में जो है आपको फ्रैगमेंटेड, डिसकंटिन्यूस और कंटिन्यूस चिप्स मिल सकती है, लेकिन मिलिंग मशीन में आपको हमेशा डिसकंटिन्यूस चिप्स मिलेंगी। सो थैंक यू सो मच फॉर वॉचिंग माई वीडियो। थैंक यू।